Hey everyone, today we'll be discussing rigid transformations and looking at shifts, reflections, and rotations in graphs. Rigid transformations are transformations that do not change the shape nor the size of the original function's shape. Here are some common types. First, we have horizontal shifts and vertical shifts and reflections. Well, we'll take C as a constant, so a shift left would be denoted by f of x equals f of x plus c. Now, the c is in the argument, so it's important to make that distinction between c being inside the argument and outside of the argument. And a shift right would be f of x equals f of x minus c. Now, this may seem counterintuitive, but I've made a more debrief video about why this holds true. But shift up and shift down is intuitive. Shift up would be f of x plus c with the c outside the argument, and shift down would be f of x minus c, also outside the argument. Let's take a look at reflections. So a reflection across the x-axis would be f of x equals negative f of x. Well, this makes sense because when you're reflecting across the x-axis, the signs of your y values change, which is denoted by negative f of x, since f of x is basically your y value. Now we're going to look at reflection across the y-axis, which is f of negative x. Now this concept holds true with the same idea as reflection across x-axis. Now let's take a look at some examples. So let's say we're given f of x equals x plus 2 squared. Let's graph the updated f of x, which we'll just call g of x, equals f of negative x plus 5 and plus 4 outside the argument. Let's describe the transformation. Note that order is really important. So first we can start off with reflection across the y-axis, then a horizontal shift 5 units left because it's plus 5, which means that it's going 5 units left, and a vertical shift 4 units up, denoted by the plus 4 outside of the argument. Now let's write out g of x. Well, we can first take it step by step, and we will just apply the horizontal transformations. And by doing that, we can replace x with negative x plus 5 equals negative x plus 5 plus 2, and all that squared. Now we replaced x with negative x plus 5 because that's what we said we would replace it with. Now we will add the vertical shift 4 units up. Well, we'll call the negative x plus 5 plus 2 squared h of x, so we'll add that vertical shift, and we have negative x plus 7 squared plus 4. And now that's our g of x, which is negative x plus 7 squared plus 4. Now we can actually graph this too, and you can see that we did actually write our g of x correctly because the blue and the green lie on the same graph, and we can see that by toggling the blue or the green on and off, and you can see that they are indeed overlapping each other, and the graph in red is our original function. I hope this video helped. Comment down below any other math topics from my review. Thank you.